Hello guys to my YouTube channel. In this course I will teach you how to write a code using the C programming language. So go subscribe to my channel to learn all the basics in C language. So let's start our course. First, what is C language? C is a general-purpose programming language created by Dennis Ritchie at the Bell Laboratories in 1972. It is a very popular language despite being old. The main reason for its popularity is because it is a fundamental language in the field of computer science. C is strongly associated with Unix as it was developed to write the Unix operating system. Why it's important to learn C? First of all, C is one of the most popular programming languages in the world. Second, C is very fast compared to other programming languages like Java and Python. Third, if you know C, you will have no problem learning other popular programming languages such as Java, Python, C++, C#, etc., as the syntax is similar. Finally, C is very versatile. It can be used in both applications and technologies. Now let's see the first program using the C language. This picture shows you how to write a code in detail in C language. The goal from this code is to print the sentence "Hello World" on the screen. In the line 1, hashtag includes dio.h is a header file library that lets us work with input and output functions, such as printf used in line 4. Header files add functionality to C programs. The line 2 is a blank line. C ignores white space, but we use it to make the code more readable. Line 3, another thing that always appear in a C program is main. This is called a function. Any code inside its curly brackets will be executed.
Line 4. Printf is a function used to output print text to the screen. In our example, it will output "Hello World." Line 5. Return 0 ends the main function. Line 6. Do not forget to add the closing curly bracket to actually end the main function. Every C statement ends with a semicolon. The body of int main could also been written as int main printf hello world, return 0. The compiler ignores white spaces. However, multiple lines make the code more readable. Now, how to print a text on the screen to output values or print text in C, you can use the printf function. My goal in this program is to print the hello world in the screen. To print this message, I use the printf function in the line 4. And this is the output after running my program. You can use as many printf functions as you want. However, note that it does not insert a new line at the end of the output. Look at this example and show how I can print 2 messages with 2 print functions. How to insert a new line. To insert a new line, you can use the /n character, like this example when I putted the new line after the hello world. You can also output multiple lines with a single printf function. However, this could make the code harder to read. 2 /n characters after each other will create a blank line. What is /n exactly? The new line character is called an escape sequence, and it forces the cursor to change its position to the beginning of the next line on the screen. This results in a new line. In this table, we have an examples of other valid escape sequences. Finally, the comment. Comments can be used to explain code and to make it more readable. It can also be used to prevent execution when testing alternative code. Comments can be single-lined or multi-lined. Single-line comments start with 2 forward slashes. Any text between this 2 slashes and the end of the line is ignored by the compiler, will not be executed. This example uses a single-line comment before a line of code. Here I have used this comment type in a different place. Multi-line comments start with /start and ends with /. Any text between /start and // will be ignored by the compiler. Now let's talk about variables in the C programming language. Variables are containers for storing data values, like numbers and characters. In C, there are different types of variables defined with different keywords. For example, first, int stores integers or the whole numbers without decimals, such as 1, 2, 3 or 1, 2, 3. Second, float stores floating point numbers with decimals, such as 1999 or 1999. Finally, char stores single characters, such as A or B. Char values are surrounded by single quotes. To create a variable, specify the type and assign it a value. Look at the general syntax. Type variable name, value, where type is one of C types, such as int, and variable name is the name of the variable, such as x or my name. The equal sign is used to assign a value to the variable.
So, to create a variable that should store a number, look at the following example. Here, I need to create a variable called mynum of type int and assign the value 15 to it. Int mynum equals 15. You can also declare a variable without assigning the value, and assign the value later. For example, first, I need to declare a variable, int mynum. Second, we will assign a value to the variable, mynum equals 15. Format specifiers are used together with the print function to tell the compiler what type of data the variable is storing. It is basically a placeholder for the variable value. A format specifier starts with a percentage sign, followed by a character. For example, to output the value of an int variable, you must use the format specifier %d or %i surrounded by double quotes, inside the print function. Int mynum equals 15. Printf, %d, mynum, and finally the output is 15. To print other types, use %c for characters and %f for float, like this example. To print different types in a single printf function, you can use the following. If you assign a new value to an existing variable, it will overwrite the previous value. Int mynum equals 15. Here, I put the first value 15. Mynum equals 10. Now the new value entered by the compiler is 10. You can also assign the value of one variable to another. Now let's learn how to add two numbers. To add a variable to another variable, you can use the plus operator. In this example, I want to add two variables x and y using the sum operator. Now how to declare multiple variables. To declare more than one variable of the same type, use a comma-separated list like this example. Now let's talk about the rules for naming a variable. First, names can contain letters, digits and underscores. Last, names must begin with a letter or an underscore. Last, names are case-sensitive. My_var and my_var are different variables. Names cannot contain white spaces or special characters like hash, %, etc. Finally, reserved words, such as int, cannot be used as names.
First, what is the data type in C? As explained in the last video, a variable in C must be a specified data type, and you must use a format specifier inside the print function to display it, like this example. First of all, we will create a variable, and enter a variable, or a whole number using the integer, a point number using the float, and finally a character using the char function. Next step, we will print the variables using the print function. Now let's show the basics data types. The data type specifies the size and type of information the variable will store. In this tutorial, We will focus on the most basic ones, like the integer, the float, character and double. First, the int, or integer, stores whole numbers, without decimals, and it have a size for 2 or 4 bytes. Second, the float, stores fractional numbers, containing 1 or more decimals, sufficient for storing 6 to 7 decimal digits. His size is 4 bytes. The double, stores fractional numbers, containing 1 or more decimals, sufficient for storing 15 decimal digits. His size is 8 bytes. Finally, the char, for the characters, stores a single character, letter, number, or ASCII values. His size is 1 byte. Now, the basics format specifiers. There are different format specifiers for each data type. Here are some of them. %D or %I is used for the integers. %F is used for float. %LF for double. %C for characters. Finally, %S used for strings, text. Set decimal precision. You have probably already noticed that if you print a floating point number, the output will show many digits after the decimal point. Look at this example. If you want to remove the extra zeros, set decimal precision, you can use a dot followed by a number that specifies how many digits that should be shown after the decimal point. Now let's take a real-life example. Here's a real-life example of using different data types to calculate and output the total cost of a number of items. First of all, I need to create variables of different data types, an integer, a decimal number, and a dollar character, and I need to use the float to calculate the total cost.
And finally, we will print our variables to find the total.
The type conversion. Sometimes, you have to convert the value of one data type to another type. This is known as type conversion. For example, if you try to divide two integers, 5 by 2, you would expect the result to be 2.5. But since we are working with integers, and not floating point values, the following example will just output 2. To get the right result, you need to know how type conversion works. There are 2 types of conversion in C. Implicit conversion, automatically. Explicit conversion, manually. First, implicit conversion. Implicit conversion is done automatically by the compiler when you assign a value of one type to another. For example, if you assign an int value to a float type. As you can see, the compiler automatically converts the int value 9 to a float value of 9.0000000. This can be risky, as you might lose control over specific values in certain situations. Especially if it was the other way around. The following example automatically converts the float value 9.99 to an int value of 9. What happened to 0.99? We might want that data in our program. So be careful. It is important that you know how the compiler works in these situations, to avoid unexpected results. As another example, if you divide two integers, 5 by 2, you know that the sum is 2.5. And as you know from the beginning of this page, if you store the sum as an integer, the result will only display the number 2. Therefore, it would be better to store the sum as a float or a double, right? Why is the result 2.0? Explicit conversion. Explicit conversion is done manually by placing the type in parentheses in front of the value. Considering our problem from the example above, we can now get the right result. You can also place the type in front of a variable, like this example. Constants in C. If you don't want others, or yourself, to change existing variable values, you can use the const keyword. This will declare the variable as constant, which means unchangeable and read-only. In this example, we have an error, because the assignment of read-only variable is my_num. You should always declare the variable as constant when you have values that are unlikely to change. Now guys, let's talk about the operators. Operators are used to perform operations on variables and values. In the example below, we use the plus operator to add together two values. In the first example, I need to calculate the sum between 150. Although the plus operator is often used to add together two values, like in the example above, it can also be used to add together a variable and a value, or a variable and another variable. C divides the operators into 5 groups: arithmetic operators, assignment operators, comparison operators, logical operators, bitwise operators. Arithmetic operators. Arithmetic operators are used to perform common mathematical operations. This table represents all of the operators with an example. We will use these operators in the exercise later. Assignment operators. Assignment operators are used to assign values to variables. In the example below, we use the assignment operator equals to assign the value 10 to a variable called x. The addition assignment operator plus equals adds a value to a variable. This is a list of all assignment operators. Comparison operators. Comparison operators are used to compare two values, or variables. This is important in programming, because it helps us to find answers and make decisions. The return value of a comparison is either 1 or 0, which means 1 for true or 0 for false. These values are known as Boolean values, and you will learn more about them in the Booleans and if-else chapter. In the following example, we use the greater than operator to find out if 5 is greater than 3. A list of all comparison operators. Logical operators. You can also test for true or false values with logical operators. Logical operators are used to determine the logic between variables or values. Size of operator. The memory size, in bytes, of a data type or a variable can be found with the size of operator. Note that we use the %lu format specifier to print the result, instead of %d. It is because the compiler expects the size of operator to return a long unsigned int, %lu, instead of int, %d. On some computers it might work with %d, but it is safer to use %lu. Why should I know the size of data types? Knowing the memory size of different data types is great when you are working with larger programs that require good memory management. Using the right data type for the right purpose will save memory and improve the performance of your program. You will learn more about the size of operator later in this tutorial, and how to use it in different scenarios. Booleans in C. Very often, in programming, you will need a data type that can only have one of two values, like yes, no, on, off, true, false. For this, C has a bool data type, which is known as booleans. Booleans represent values that are either true or false. Boolean variables. In C, the bool type is not a built-in data type, like integer or characters. It was introduced in C99, and you must import the following header file to use it. A Boolean variable is declared with the bool keyword and can only take the values true or false. Before trying to print the Boolean variables, you should know that Boolean values are returned as integers. 1, or any other number that is not 0, represents true. 0 represents false. Therefore, you must use the %d format specifier to print a Boolean value. Comparing values and variables. Comparing values are useful in programming, because it helps us to find answers and make decisions. For example, you can use a comparison operator, such as the greater than operator, to compare two values. You can also compare two variables. In the example below, we use the equal to operator to compare different values. Conditions and if statements. You have already learned that C supports the usual logical conditions from mathematics. Less than or equal to, greater than or equal to, not equal to. You can use these conditions to perform different actions for different decisions. C has the following conditional statements. Use if to specify a block of code to be executed, if a specified condition is true. Use else to specify a block of code to be executed, if the same condition is false. Use else if to specify a new condition to test, if the first condition is false. Use switch to specify many alternative blocks of code to be executed. The if statement. Use the if statement to specify a block of code to be executed if a condition is true. This is the syntax of if statement. We write if with a condition, and we write the block of code in the braces. Note that if is in lowercase letters. Uppercase letters will generate an error. In the example below, we test two values to find out if 20 is greater than 18. If the condition is true, print some text. In this example, we use two variables, x and y, to test whether x is greater than y, using the greater than operator. As x is 20, and y is 18, and we know that 20 is greater than 18, we print to the screen that x is greater than y. The else statement. Use the else statement to specify a block of code to be executed if the condition is false. Here we open two braces, one for the if statement and other for the else statement. In this example, time, 20, is greater than 18, so the condition is false. Because of this, we move on to the else condition and print to the screen good evening. If the time was less than 18, the program would print good day. The else if statement. Use the else if statement to specify a new condition if the first condition is false. And this is the else if syntax. In this example, time, 22, is greater than 10, so the first condition is false. The next condition, in the else if statement, is also false, so we move on to the else condition since condition 1 and condition 2 is both false, and print to the screen good evening. However, if the time was 14, our program would print good day. Now, the switch statement. Instead of writing many if, else statements, you can use the switch statement. The switch statement selects one of many code blocks to be executed, like this syntax. This is how it works. The switch expression is evaluated once. The value of the expression is compared with the values of each case. If there is a match, the associated block of code is executed. The break statement breaks out of the switch block and stops the execution. The default statement is optional, and specifies some code to run if there is no case match. The example below uses the weekday number to calculate the weekday name. The output here is Thursday or day 4. The break keyword. When C reaches a break keyword, it breaks out of the switch block. This will stop the execution of more code and case testing inside the block. When a match is found, and the job is done, it's time for a break. There is no need for more testing. A break can save a lot of execution time because it ignores the execution of all the rest of the code in the switch block. The default keyword specifies some code to run if there is no case match. Note that the default keyword must be used as the last statement in the switch, and it does not need a break. Now, let's talk about the loops. Loops can execute a block of code as long as a specified condition is reached. Loops are handy because they save time, reduce errors, and they make code more readable. While loop. The while loop loops through a block of code as long as a specified condition is true. In the example below, the code in the loop will run, over and over again, as long as a variable I is less than 5. Do not forget to increase the variable used in the condition I++, otherwise the loop will never end. The do/while loop. The do/while loop is a variant of the while loop. This loop will execute the code block once, before checking if the condition is true, then it will repeat the loop as long as the condition is true. The example below uses a do-while loop. The loop will always be executed at least once, even if the condition is false, because the code block is executed before the condition is tested. Do not forget to increase the variable used in the condition, otherwise the loop will never end. For a loop. When you know exactly how many times you want to loop through a block of code, use the for loop instead of a while loop. In the syntax, statement 1 is executed one time before the execution of the code block. Statement 2 defines the condition for executing the code block. Statement 3 is executed every time after the code block has been executed. The example below will print the numbers 0 to 4. Statement 1 sets a variable before the loop starts, int I equals 0. Statement 2 defines the condition for the loop to run, I must be less than 5. If the condition is true, the loop will start over again. If it is false, the loop will end. Statement 3 increases a value, I++, each time the code block in the loop has been executed. Nested loops. It is also possible to place a loop inside another loop. This is called a nested loop. The inner loop will be executed one time for each iteration of the outer loop. Break. You have already seen the break statement used in an earlier chapter of this tutorial. It was used to jump out of a switch statement. The break statement can also be used to jump out of a loop. This example jumps out of the for loop when I is equal to 4. Continue. The continue statement breaks one iteration in the loop if a specified condition occurs, and continues with the next iteration in the loop. This example skips the value of 4. You can also use break and continue in while loops. Arrays. Arrays are used to store multiple values in a single variable, instead of declaring separate variables for each value. To create an array, define the data type, like int, and specify the name of the array followed by square brackets. To insert values to it, use a comma-separated list, inside curly braces, like this example. We have now created a variable that holds an array of 4 integers. Access the elements of an array. To access an array element, refer to its index number. Array indexes start with 0, 0 is the first element, 1 is the second element, etc. This statement accesses the value of the first element, 0. In my numbers, the value of the first element is 25. Now, how to change an array element. To change the value of a specific element, refer to the index number. In the last example, if I need to change the value of the first element to 33, after the declaration of the array I write my number 0, equal to 33. And finally I get 33 instead of 25. Loop through an array. You can loop through the array elements with the for loop. The following example outputs all elements in the myNumbers array. Set array size. Another common way to create arrays is to specify the size of the array and add elements later. Using this method, you should know the number of array elements in advance, in order for the program to store enough memory. You are not able to change the size of the array after creation. Get array size or length. To get the size of an array, you can use the sizeOf operator, like the first example. Why did the result show 20 instead of 5, when the array contains 5 elements? It is because the sizeOf operator returns the size of a type in bytes. You learned from the data types chapter that an int type is usually 4 bytes, so from the example above, 4 by 5 it's mean 4 bytes x 5 elements equals 20 bytes. Knowing the memory size of an array is great when you are working with larger programs that require good memory management. But when you just want to find out how many elements an array has, you can use the following formula, which divides the size of the array by the size of one array element, like the second example. Making better loops. In the array loops section in the previous chapter, we wrote the size of the array in the loop condition, ILT, 4. This is not ideal, since it will only work for arrays of a specified size. However, by using the size of formula from the example above, we can now make loops that work for arrays of any size, which is more sustainable. What is a multidimensional arrays? In the previous chapter, you learned about arrays, which is also known as single-dimension arrays. These are great, and something you will use a lot while programming in C. However, if you want to store data as a tabular form, like a table with rows and columns, you need to get familiar with multidimensional arrays. A multidimensional array is basically an array of arrays. Arrays can have any number of dimensions. In this chapter, we will introduce the most common, two-dimensional arrays, 2D. Two-dimensional arrays. A 2D array is also known as a matrix, a table of rows and columns.
To create a 2D array of integers, take a look at the following example.
The first dimension represents the number of rows, 2, while the second dimension represents the number of columns, 3. The values are placed in row order, and can be visualized like this table. Let's talk about the strings. Strings are used for storing text or characters. For example, Hello World is a string of characters. Unlike many other programming languages, C does not have a string type to easily create string variables. Instead, you must use the char type and create an array of characters to make a string in C, like this example. Note that you have to use double quotes. To output the string, you can use the print function together with the format specifier %s to tell C that we are now working with strings. Access strings. Since strings are actually arrays in C, you can access a string by referring to its index number inside square brackets. This example prints the first character, 0, in greetings. Note that we have to use the %C format specifier to print a single character. Modify strings. To change the value of a specific character in a string, refer to the index number, and use single quotes, like this example. Loop through a string. You can also loop through the characters of a string, using a for loop, like the first example. And like we specified in the arrays chapter, you can also use the size of formula, instead of manually write the size of the array in the loop condition ILT, 5, to make the loop more sustainable. Another way of creating strings. In the examples above, we used a string literal to create a string variable. This is the easiest way to create a string in C. You should also note that you can create a string with a set of characters. This example will produce the same result as the example in the beginning of this page. Why do we include the \0 character at the end? This is known as the null terminating character, and must be included when creating strings using this method. It tells C that this is the end of the string. Differences. The difference between the two ways of creating strings is that the first method is easier to write, and you do not have to include the \0 character, as C will do it for you. You should note that the size of both arrays is the same, they both have 13 characters. Space also counts as a character by the way, including the \0 character. Special characters used in strings. Because strings must be written within quotes, C will misunderstand this string, and generate an error like this example. The solution to avoid this problem is to use the \escape character. The \escape character turns special characters into string characters. This is 3 examples how to use the \. This is other popular escape characters in C are, like the new line, new tab, and null. User input. You have already learned that printf is used to output values in C. To get user input, you can use the scan function. In this example, we want to output a number entered by the user. The scan function takes two arguments, the format specifier of the variable, %d in the example above, and the reference operator amp, mynum, which stores the memory address of the variable. Multiple inputs. The scan function also allows multiple inputs, an integer and a character in the following example. Take string input. You can also get a string entered by the user, like this example. Note that when working with strings in scanf, you must specify the size of the string or array. We used a very high number, 30 in our example, but at least then we are certain it will store enough characters for the first name, and you don't have to use the reference operator. However, the scanf function has some limitations. It considers space, whitespace, tabs, etc., as a terminating character, which means that it can only display a single word, even if you type many words. In this example, you would expect the program to print John Doe, but it only prints John. That's why, when working with strings, we often use the fgets function to read a line of text. Note that you must include the following arguments: the name of the string variable, size of, string name, and stdin. Use the scanf function to get a single word as input, and use fgets for multiple words. Memory address. When a variable is created in C, a memory address is assigned to the variable. The memory address is the location of where the variable is stored on the computer. When we assign a value to the variable, it is stored in this memory address. To access it, use the reference operator, and the result represents where the variable is stored. The memory address is in hexadecimal form. You will probably not get the same result in your program, as this depends on where the variable is stored on your computer. You should also note that amp, myAge, is often called a pointer. A pointer basically stores the memory address of a variable as its value. To print pointer values, we use the %p format specifier with the reference operator. A pointer is a variable that stores the memory address of another variable as its value. A pointer variable points to a data type, like int, of the same type, and is created with the operator. The address of the variable you are working with is assigned to the pointer. Create a pointer variable with the name ptr that points to an int variable, myAge. Note that the type of the pointer has to match the type of the variable you are working with, int in our example. Use the amp operator to store the memory address of the myAge variable, and assign it to the pointer. Now, ptr holds the value of myAge's memory address. Dereference. In the example above, we used the pointer variable to get the memory address of a variable, used together with the amp reference operator. You can also get the value of the variable the pointer points to, by using the operator, the dereference operator. Note that the sign can be confusing here, as it does two different things in our code. When used in declaration, in ptr, it creates a pointer variable. When not used in declaration, it acts as a dereference operator. Pointers are one of the things that make C stand out from other programming languages, like Python and Java. They are important in C, because they allow us to manipulate the data in the computer's memory. This can reduce the code and improve the performance. If you are familiar with data structures like lists, trees and graphs, you should know that pointers are especially useful for implementing those. And sometimes you even have to use pointers, for example when working with files. Pointers amp, arrays. You can also use pointers to access arrays. Consider the following array of integers. You learned from the arrays chapter that you can loop through the array elements with a for loop. How are pointers related to arrays? Okay, so what's the relationship between pointers and arrays? Well, in C, the name of an array is actually a pointer to the first element of the array. Confused? Let's try to understand this better, and use our memory address example above again. The memory address of the first element is the same as the name of the array. This basically means that we can work with arrays through pointers. How? Since myNumbers is a pointer to the first element in myNumbers, you can use the operator to access it. To access the rest of the elements in myNumbers, you can increment the pointer or array, +1, +2, etc. Also you can use the loops like here. It is also possible to change the value of array elements with pointers. This way of working with arrays might seem a bit excessive, especially with simple arrays like in the examples above. However, for large arrays, it can be much more efficient to access and manipulate arrays with pointers. It is also considered faster and easier to access two-dimensional arrays with pointers. And since strings are actually arrays, you can also use pointers to access strings. What is a function? A function is a block of code which only runs when it is called. You can pass data, known as parameters, into a function. Functions are used to perform certain actions, and they are important for reusing code. Define the code once, and use it many times. Predefined functions. So it turns out you already know what a function is. For example, main is a function, which is used to execute code, and printf is a function, used to output/print text to the screen. How to create a function. To create, often referred to as declare, your own function, specify the name of the function, followed by parentheses and curly brackets. My function is the name of the function. Void means that the function does not have a return value. You will learn more about return values later in the next chapter. Inside the function, the body, add code that defines what the function should do. Call a function. Declared functions are not executed immediately. They are saved for later use, and will be executed when they are called.
To call a function, write the function's name followed by 2 parentheses and a semicolon.
In the following example, my function is used to print a text, the action, when it is called. Parameters and arguments. Information can be passed to functions as a parameter. Parameters act as variables inside the function. Parameters are specified after the function name, inside the parentheses. You can add as many parameters as you want, just separate them with a comma. The following function that takes a string of characters with name as parameter. When the function is called, we pass along a name, which is used inside the function to print hello and the name of each person. When a parameter is passed to the function, it is called an argument. So, from this example, name is a parameter, while Liam, Jenny and Anya are arguments. Multiple parameters. Inside the function, you can add as many parameters as you want. Note that when you are working with multiple parameters, the function call must have the same number of arguments as there are parameters, and the arguments must be passed in the same order. Pass arrays as function parameters. You can also pass arrays to a function. The function, my function, takes an array as its parameter, int myNumbers5, and loops through the array elements with the for loop. When the function is called inside main, we pass along the myNumbers array, which outputs the array elements. Note that when you call the function, you only need to use the name of the array when passing it as an argument my function myNumbers. However, the full declaration of the array is needed in the function parameter, int myNumbers5. Return values. The void keyword, used in the previous examples, indicates that the function should not return a value. If you want the function to return a value, you can use a data type, such as int or float, etc., instead of void, and use the return keyword inside the function. Function declaration and definition. You just learned from the previous chapters that you can create and call a function in the following way. A function consists of 2 parts. Declaration, the function's name, return type, and parameters, if any. Definition: the body of the function, code to be executed. For code optimization, it is recommended to separate the declaration and the definition of the function. You will often see C programs that have function declaration above main, and function definition below main. This will make the code better organized and easier to read. Math functions. There is also a list of math functions available that allows you to perform mathematical tasks on numbers. To use them, you must include the math.h header file in your program. Square root. To find the square root of a number, use the sqrt function. Round a number. The ceil function rounds a number upwards to its nearest integer, and the floor method rounds a number downwards to its nearest integer, and returns the result. That's all for today. Don't forget to subscribe to my channel and support me for more videos. Thank you for watching.